Hi guys, very warm welcome to the Linear Regression with Python using Scikit-Learn lecture. In the theory lecture, we have learned the key concepts and working principle behind the linear regression model. It's time to learn by doing. I'm very excited because you have put tremendous amount of efforts to come to this stage where we are doing our first machine learning project. We will go through the process step by step. It is important so that we understand the next lectures without going through these steps in details. However, we will revise these steps several times along our way in the machine learning section. Let's start with a very famous and real dataset. Our task is to build a machine learning model to predict the housing price in Boston area. This housing dataset is a part of Scikit-Learn and also available on Kaggle for you to download. A CSV file is already included in the course material. However, you can follow this link to explore more on this dataset. So moving forward, let's use the one which is already included in Scikit-Learn dataset repository so that you get to know the process to load the built-in datasets from Scikit-Learn as well. Let's start by creating a real-life situation here. Suppose you are hired by a real estate company to help them in their business goals. The company wants you to predict the housing prices in Boston area. Based on the community and safety issues, some areas are in demand. The company is interested in some kind of automated way of suggesting the price of a house based on its features. You are given a dataset that contains features such as crime rate by town, proportion of residential land, nitric oxide concentration, age of the house, property tax, and so on. You are happy and very excited to help because you got a job to do. Now, when you look at the dataset, you realize that the linear regression is going to be a good model to work with in this type of problem. So details on the full list of features is provided in the reference notebook, where CRIM is per capita crime rate by town, ZN proportion for residential land, RM average number of rooms and age of the house, taxes, and so on. Let's move on and build our first machine learning model using the given data. We will start with the new Jupyter notebook file, notebook and Python 3. We need to import pandas, numpy, matplotlib, and seaborn. So import pandas as pd, import numpy as np, import matplotlib.pyplot as plt, and import seaborn as sns. Let's set matplotlib inline so that we can see the plots within the Jupyter notebook. Matplotlib inline. Let's run this cell and we are done with these imports. Let's import datasets from Scikit-Learn. So from Scikit-Learn, import datasets and run this cell. Let's load the built-in housing price dataset Boston into BH. So BH equal to datasets dot load. So the first one is our Boston dataset. So datasets dot load Boston. Let's run this cell. Now we have our Boston dataset in BH. Boston dataset is essentially a dictionary. Let's check its keys. BH dot keys here, and if we run, so it contains data, target, which is the price, feature names are the columns, and DESCR is the description on the data. Let's add few lines and check the description here. BH, and we can copy and paste here. And if we run this cell, here is the description on the dataset. It does look very nice. Let's use the print function here. And rerun this cell. Here we have the description. Boston housing price dataset. Note dataset characteristics, number of instances, number of attributes, and more on the columns and their descriptions. It's mentioned that the Boston house price data has been used in many machine learning papers that address regression problem. Couple of references and so on. Let's check the feature names now. We can simply call bh dot feature names. And if we run this cell, we have all the features CRIM, ZN, Indus, and so on. So these are the features here with their description. So moving forward, let's create a pandas data frame with features as column names. Let's run this cell and check the head of the data frame, df dot head. And here we have our data frame. Let's add target values as a new column price in this dataset. I hope you remember how to add a new column in your data frame. So in this case, df, the name what we want here, price, and we have bh dot target. Let's check the head of data frame after adding new column. So df dot head. Let's run this cell, and here we have a new column price in our data frame. So let's move on and call info function on our data frame now. df dot info. Run this cell, and here we have a summary on our data frame. We have 506 entries and column names, and the price, the column we have recently added. So let's add few lines again and have a quick view on some statistical information of our dataset. We can use describe here. So df dot describe and run this cell. And here we have some statistical information on our dataset: count, mean, standard deviation, minimum, 25, 50, 70, and max here for all the numerical columns in our data frame. It's always good to understand your data. You need to do some exploratory data analysis. In this lecture, we are focusing towards machine learning, but still we will do some exploratory data analysis before we move on to the machine learning. Let's do some exploratory data analysis. We can plot a histogram of the price column here. So plt dot hist, pass in price column, and let's run this cell here. And this is our histogram for the price column. Let's change the bin size, say 50, add x and y labels, plt dot x, and this is price in thousands, plt dot y label, and we have count here, And let's rerun this cell. Here we have our plot again. We have price along x-axis and number of occurrences along y-axis. So if we look at the histogram, most of the prices are in 20s. We notice that the average price is around 22K. There are some houses in 50s as well. If you want, you can drop these rows where the houses are in 50s. At the moment, we are going to keep them in our data. So moving forward, let's have a quick overview on selected features in our dataset. Seaborn's pair plot function is a good option. Although we can plot all the features, but the pair plot would be very crowded if we use all the features in the pair plot option. Let's plot some important features to see how they are related to each other. We can check how the crime rate, number of rooms, age of the house, percentage lower status of the population, weighted distances to 5 Boston employment centers, and price are related to each other. Let's select these columns. We can call SNS dot pair plot and pass in the list of columns that we want. So DF, and we want crime, RM is room numbers, age, L stat, which is percentage lower status of the population, DIS is the weighted distances to 5 Boston employment centers, ZN proportional of residential zone, and price. Let's run this cell. This takes some time because we are loading a big plot here. So here we have a complete pair plot. Let's fit to the screen. So this is quite big, like 1, 2, 3, 4, 5, 6, 7 columns and 1, 2, 3, 4, 5, 6, 7 rows. This is quite big. Let's have a quick look on the last row only. We have price here and we have all the selected features along x-axis. We see some trends here, like room number and price are related. This one here has some trends with price and so on. You can always explore more on your dataset. Let's see how the correlation between selected features look like using heat map. We can copy this code here, and instead of pair plot, we want heat map, and we want the correlation. So let's call correlation here, CORR, and let's run this cell. And here we have a heat map for the selected features. Let's make it slightly bigger, so this is better looking. We can put values on the heat map as well. So note equal to true and rerun. And here we have the correlation values. So if we look at this heat map, every column is perfectly correlated to itself along diagonal. Number of rooms have the highest value for price. This makes sense. More the rooms are, higher the price is. On the other hand, age has a negative correlation with price. This also makes sense. If the house is older, one should expect the lower price for that house. You can spend more time on exploratory data analysis. You can get more plots and see how much information you can get from your dataset. Our focus in this lecture is machine learning model, and we will not spend more time on exploratory data analysis. Let's move on to the machine learning now using Scikit-Learn. The very first thing we need to do is we need to separate our dataset into two arrays, X and Y. X is typically the selected features and y is the target values. In this case, we have price as a y and all other features are x. Please note, we are going to use the selected features in this model. So we need to pass in the column names for those selected features. Later on, you can recreate your model using all features in the dataset and see how your model is different when you are using all features and when you're using some important features. So let's separate the data into x and y. X equal to df and selected features, we are going to select ZN, which is residential zone. Crime is also important. Room number is important. We have seen that age is important as well. L stat, and let's take distance as well. And our Y is df and price. Let's run this cell and check x dot head, and here we have the selected features ZN, crime, room, age, LSTAT, and distance. If we check the head of y here, y dot head, and run this cell, and here we have the targeted values, which is price. Let's add few lines and move on to the linear regression model training. I'm going to split this lecture here because it is getting long. We will start from the same point in the next lecture. See you in the next lecture. Good luck.